Hi, everybody. Here is Martin, machine learning from Machine Learning Meetups Bratislava team. Today, our speaker, Fridolin Pokorny, will talk about reinforcement learning based on dependency resolution. But first, we have to thank to our sponsors, which are for this season Seznam, SAS, Rossum, Datacentrix, and Konica Minolta. Our speaker, Fridolin, is a passionate Pythonist working on scalable platforms and machine learning applications in Red Hat's office. Please, if you have any questions, post them to our Slido channel with hashtag MLMU. We will focus on them after the talk. Now, Fridolin, stage is yours.
Okay, thank you. Let me share my screen. Okay, just to double check, can you see my screen?
Yes.
Okay, thank you. So, hello everyone, my name is Fridolin, and welcome to this presentation that will be showing what we do at Red Hat. And I will talk about Project Thoth, specifically for one component that we have, and that is reinforcement learning-based dependency resolution. First, I will talk about what we do in general, who we are, and why this project was born. And then I will show you some results that we have, and how you can contribute to our system, or where you can find us in case you are interested in these things and you would like to use our software and tooling that is open source, available on GitHub. So I'm one of the members of a team that is called AICOV, that is AI Center of Excellence. We do emerging technologies in Red Hat's Office of the CTO, where we basically show what are emerging technologies, how company, but also communities can adopt these technologies. And specifically, I work on scalable platforms and machine learning applications. The project I work on is primarily focused on Python as a programming language, and our main goal is to create Python community and Python ecosystem that is a nice place to code and develop applications. In general, we are developing new tools and platforms in order to provide a better experience for developers, but we are also improving data science experience. Another team, Open Data Hub, is a platform providing open platform for developing data-centric applications. We try to develop bots, so everything that we do is automated. As you will see, we are a few members, and we would like to be productive as any other developers, and we don't want to spend much time on mundane work. The team I work in is called Project Thoth. So we are resurrecting ancient deities. If you take a look at our web page, it will link you to GitHub repositories, and these GitHub repositories have different names of ancient deities. So, for example, you can find Amun, Thoth, and others. When it comes to people and developers, you can see all the members listed on the slide. We are a distributed team. You can find people in US, Germany, Italy, here in Brno. And if you want to become a member, we have also a job posting, so feel free to reach out to us. Now, let's dive into problematics, and let's see what problem we are trying to solve. If you develop an application, you most certainly know that it's not just that application that you develop, but you want to use libraries that are available out there and that are open source. So if you're developing a Python application, you want to use, for example, a machine learning library that is TensorFlow. So you install TensorFlow, but at the same time, you don't install TensorFlow because TensorFlow on its own uses some libraries. And I will refer to these libraries as transitive dependencies of your direct dependencies. These libraries, but also TensorFlow, can use some native dependencies such as glibc, and all is running inside some Python interpreter that can have different versions, different patches that are applied to interpreter, for example, because of performance and stuff like that. Then you have operating system that provides kernel modules. For example, in case of TensorFlow, you can have GPU drivers that are running in the kernel space and provides a way how you can use GPU cards from applications that are developed in the user space. Then the operating system is run on some hardware. And as you can see, we create a layer of different software and also hardware that is included. And if there is any issue in any layer, then your application simply misbehaves or produces wrong errors. You can focus also on other aspects, other quality of software. For example, you can check performance, so how well performing your machine learning model is, but you can also focus on security. So if you're deploying some machine learning model to your production environment, you want to check if your application does not come with some security vulnerabilities that are, for example, found inside TensorFlow. So let's try to find a way how to find the right set of dependencies, right set of direct dependencies, but also transitive ones for your application, so the application runs smoothly and these aspects of quality are taken into account. First, let's dive into these problematics from, let's say, mathematical perspective. So let's say that we are developing an application that uses just two libraries. The first one is called simplib, the other one is called anotherlib. And these libraries do not have any dependencies. So when you perform something like pip install simplib, anotherlib, then it's just simplib and anotherlib that is present inside your Python environment. Then let's suppose that we install these libraries in different versions. So we create different combinations of versions of simplib and different versions of anotherlib installed together. And then we will use some scoring function, which tells us how good the given software is. What it can include, like how good the software is. It can include these observations that I stated, like does it perform well? Is your application well performing? Is it security? Is it secure? Has it any security vulnerabilities and stuff like that? So if this function takes into account these aspects of software, then we can plot how the function looks like. So considering different versions of simplib and different versions of anotherlib, we have different score. We are in discrete space, so let's try to interpolate these dots. And what we get a surface. This surface basically shows how the software is performing with respect to your requirement on quality. If you use pip, pipenv, poetry, or other resolvers that are available in Python universe, then these tools resolve software that is always the latest possible. So in this case, it would be somewhere here. If you take a look at scores, even for less recent releases of anotherlib, it's still low. And we can observe this in Python ecosystem, but also in other programming languages as well. So the latest is not always the greatest software. And if you take a look, for example, to some older releases of software. They can be, for example, performing better because there are no regression, or there were created patch releases, so there are no vulnerabilities and stuff like that. The scoring function can take into account security, so vulnerabilities present in software. You can take it into account performance aspects of your software, but it can also use some more complex scoring that will take into account the security vulnerabilities, as well as performance aspects, or any aspect you can think of about your software that you use. Now, if we adopt this idea into real-world applications, we need to consider not just these direct dependencies, but also transitive dependencies, because libraries have dependencies and they depend on other dependencies, and also runtime environments that you run in. So, for example, if you're running Fedora, Red Hat Enterprise Linux, Universal Base Images, or any other containerized environments, you need to take into account also software that is present inside these environments. So we have a lot of aspects to consider. And also when we tried to enumerate number of combinations that are out there for a TensorFlow stack, we used one specific version of TensorFlow, that was TensorFlow 2.1.0, that is published on PyPI. And we found that there are more than 3 multiplied by 10 to the power of 13 combinations how to install TensorFlow with respect to its transitive dependencies. Moreover, this number can grow if there are, for example, overpinning issues. So new releases can be included into TensorFlow stack over time and can break software. We conducted few experiments that showed that these issues that I described really exist in the Python ecosystem, and we found that some dependencies deep down in a TensorFlow stack broke applications. So TensorFlow did not start at all. That also shows that it's not possible to test TensorFlow for all the combinations. So you see that the number is very large. So how do we approach this problem, and how to solve this optimization problem? Let's have a look at TensorFlow graph. So you can see that TensorFlow in the release 2.1.0 had 23 direct dependencies, stating dependency name and version range specification that again can resolve to different versions. So here you can see ABSLPy that has different versions resolved into something over time. But you can see that the dependency graph shares nodes. So for example, here you can see that NumPy is a dependency of opt-zoom. It's also direct dependency of TensorFlow, and it's also a dependency of SciPy. So this dependency graph is something complex, and resolution algorithm needs to take into account all these aspects when resolving some software. So what we can do, we can choose some packages randomly. So let's say we are resolving TensorFlow in version 2.1.0 because that's the direct dependency of our application, and the resolver can randomly pick some version of ABSLPy, some version of NumPy, some version of SciPy, respecting these version range specifications that were put in there by TensorFlow maintainers, but also respecting these version ranges for other transitive dependencies, so the resolution is valid. We call this random state space sampling, and that's basically resolving some software stack, resolving some set of packages, and these set of packages go through something that is called scoring pipeline that says how good the given set of packages is with respect to the quality that is inspected. And that's basically the idea behind the state space. So we just randomly pick one version, then we randomly pick another version that is still valid, and we check what's the overall score of this combination. In our simplified scenario, we had this plot that was 3D plot, one dimension from one package, another dimension for another package, another leap, simple leap, and then we had the final score, so we had 3 dimensions. If we consider TensorFlow, we had 23 direct dependencies. There were also some transitive dependencies, so the scoring function is more than 24 dimensional function, one dimension for the scoring. So you can see that the problem is quite complex to tackle and requires some engineering effort. At first, we tried really randomly resolve software, check the quality, and by randomly picking some set of packages, we were trying to find some good enough candidate that we would say this is the right software that you can use. Over time, the software evolved. We tried also different approaches. And the main idea that was behind reinforcement learning resolution was that, okay, let's start to exploring how these packages look like, what is their quality. Let's try to randomly sample the state space of resolved software stacks. So we randomly include packages into our application. We check the quality. And we learn. So we basically explore the world state space. We learn how it looks like, what scores these packages produce. And then we plugged gradient-free methods, specifically temporal difference learning, also known as TD learning, and Monte Carlo tree search. And these methods basically use the aggregated knowledge about packages, how do they affect the overall score of software that is shipped, and try to guide the whole resolution process so that there is recommended the best possible software, meaning best possible set of packages that can be used in your application. I already stated that we have some scoring pipeline that basically checks the score of packages. You can think about it as a pipeline which takes a look at the package that is about to be included in your application. So it can be, in case of TensorFlow stack, it can be an NumPy in some version. And the scoring pipeline decides if including that NumPy in that specific version in your application stack is good or not good. Does it, for example, break the application, or does it produce performance degradation and stuff like that? If you know temporal difference learning or Monte Carlo tree search, you know that there is a need to balance the exploration phase. That's the phase when the algorithm randomly tries to sample the whole state space and learns how the state space looks like. And that needs to be balanced with exploitation phase. This exploitation phase basically says how to guide the resolution process so that the candidate that is resolved has the highest possible value. We created one example scenario that is recommending a Flask application. So in this case, the algorithm was looking for some Flask stack. So if you install Flask in any version with any transitive and also direct dependencies, you end up with 7 packages considered in total. So Flask depends on, for example, Werkzeug and other packages. And these 7 packages create more than 7 million possible valid software stack resolutions. So there are more than 7 million possibilities how to install Flask. We randomly assign scores to packages that were resolved. So Flask in different versions had different scores, so that we prove that the reinforcement learning algorithm works. Then we we created or we instrumented the resolver just to resolve 70,000 stacks, so roughly 1% of all the possible software stacks. And we wanted to check if the resolution algorithm finds a good enough candidate that would be recommended to users. So users use right software for Flask application without, for example, security vulnerabilities. I can show you the result of experiments. That is basically a Jupyter notebook that is demonstrating gradient-free methods. So you can find it on Thoth Station organization, GitHub, inside notebooks repository, and it will guide you through the whole resolution process, all the configuration that is supplied to the resolver, together with the scoring pipeline, and also information about packages that are included. So here you can see different packages that are included in the resolution process. So as stated, Flask, Werkzeug, Flask, Werkzeug is dangerous, and other packages that are dependencies of Flask, together with a number of versions that are available on PyPI. So you can go through this notebook. It also shows different approaches with different configurations of the algorithm, so different combinations of temporal difference learning, and you can find how the algorithm behaves. What I will show you the last experiment, the most relevant one, and I will try to demonstrate how it works. So as stated, there were more than 7 million possible combinations how to install Flask. And based on scores that were statically assigned to packages, the highest rated set of packages that would be recommended had a score of 5.04. The resolver did not look through the whole state space, but rather performed exploration phase and then exploitation phase, and found a software stack that is quite close to the highest rated candidate. So how the algorithm works. I will describe first plot that is on the left-hand side. Here you can see temperature that is on y-axis. This temperature is basically temperature from simulated annealing. And as you can see, the temperature starts on some very high value, and over time it decreases. So here you can see a number of iterations that are performed during the resolution process. So these are basically rounds of a resolver. So the temperature starts at some high value, and over time it decreases. This is adaptive simulated annealing, and it considers a number of iterations that are done inside resolver, time spent during resolution, and stuff like that. So this is how the exploitation and exploration phase are balanced. Over time, as temperature decreases, the probability of randomly sampling the state space also decreases. That means that the algorithm slowly switches to exploitation phase and is always picking the highest rated candidate for resolution. And that's basically what this graph shows. These red lines show a random candidate that is picked for resolution, and the green ones show the highest rated during exploitation phase. The plot on right-hand side shows score of the resolved software stacks. So in the exploration phase, we basically randomly sample the whole state space, and that means that the score of resolved software stacks, resolved combinations of packages that are installed is random. But over time, this switches, the algorithm switches to exploitation phase, and in that case, the score of highest rated software stack is, or the score of resolved software stack is very high. That can be seen in these green dots. When you take a look at blue dots, you can see, or blue lines, you can see the best software stack that is found during the whole resolution process. So at the beginning, the resolver found some very low rated software stack, and over time it improved and found better and better candidate. At the end, here it found the highest rated software stack that stayed high value for the rest of the resolution. So this briefly describes how the algorithm works. In order to keep the resolution process responsive, this cannot be done locally on your machine. That means that there needs to be a service that will provide you these resolutions. So Thoth is server-side resolution engine. And what we do on the server side, backend is aggregating data. So it, for example, analyzes packages, their dependencies, their quality, and based on these analyses, we store data inside the database, so the resolution can be done offline without actually installing these packages as, for example, pip or pipenv for poetry do. Here you can see a screenshot of our Grafana dashboards. We use open source software, so Grafana is our component that shows how the system behaves. You can see different integrations, how many people are using our services. This screenshot is taken from our stage environment, so there are not that much people, but what is interesting is the aggregation part, where we aggregated information for more than 2 million releases that are available on PyPI, so more than 200,000 packages that are available on publicly hosted PyPI. We found also errors that can be encountered in case of using packages. For example, some packages are released just for Python 2, and they do not support Python 3, and that means that they produce errors when they are installed inside Python 3 environments. So you have a brief overview of data that we aggregate and numbers. Then I would like to show you one of the integration that we have, that is Jupyter notebooks. When you browse GitHub and you check Jupyter notebooks that are available publicly and published by community, but even if you take a look at notebooks that are published on Google Colab, you see lines like this one. So people tend to write their requirements inside cell and issue directly installation process using pip, like pip install TensorFlow, pip install Boto, pip install Matplotlib. I would consider this as a disease. This is really something that people should not do, because if you go back to this notebook 1 year later, I'm pretty sure that this notebook will not work. For example, TensorFlow API is changing with each release quite frequently, and there is basically no traceability with respect to libraries and their versions that were used during this notebook run. You can use logs of the notebook if you store them that were produced during the installation process, but this is really something that people should not do, and this will result in wrong software. We have solution for this, so if you're interested in that solution, we will soon publish a blog post about an extension that you can use inside your Jupyter notebooks and your Jupyter environments so that your dependencies are properly managed. If you want to stay in touch with us, you can follow Twitter for more updates. We will definitely tweet about it. And here you can see just a brief overview of it. So it's a Jupyter Lab extension that you can install, and you can manage your dependencies using clicking inside Jupyter Lab UI. Another thing that we do is automatic dependency management for people. So we run quite an extensive infrastructure just to keep these analyzers running. And we have more than 100 repositories that state different parts of software, and these repositories needs to be up to date. If we would run manual updates of dependencies, we would need to dedicate one engineer that would just go through the repositories and make sure that the software is up to date and all the components work together. That's why we developed bots. So one of our bots is called Quebec, and this bot can automatically manage repositories and issue updates when it spots that there are new releases of packages. It automatically opens a pull request, a pipeline that is verifying software correctness runs. It verifies that the right software is installed, that your application runs correctly with respect to tests available inside your application, and that the update is correct. In that case, the bot automatically approves the pull request, and the pull request is also automatically merged. So this is really a time saver for us, and we can focus on important parts and important aspects of applications, not to spend much time on mundane work. Another feature is new RR releases. So the bot can automatically release your software. The only thing you need to do is create an issue with a specific title. Then the bot self-assigns the issue, starts working on it, creates a pull request to a repository stating what changed across releases, automatically bumps versions in your sources, automatically creates changelog using machine learning, so automatically groups messages into categories, for example, automatic updates, features, bug fixes, and stuff like that. This is automatically verified by the pipeline and automatically merged if the release is correct. Also, the release is published on your Python index. In this case, it is PyPI, the publicly hosted service. Once this is done, there is also created a tag inside your Git repository stating what happened, what release was made, and the bot automatically closed the pull request, so you can see that the mundane work is left on machines. If you're interested in these things, you can use our services. So we are open source. Specifically, if you are interested in Quebec, you can install it using GitHub Application Store. We also produce data that are data science centric, so you can follow us on Kaggle. You can download these data sets, experiment with them. We also publish notebooks, and we are open source. So if you want to contribute or you want to check what's going on here, we have planning that is done openly, and the whole world can see it. You can also take a look at our homepage, that is ThothStation Ninja, that will direct you to different parts, for example, the documentation, how to set up the bot, or you can also follow us on Twitter for updates. And as we are open also when it comes to our demos and Scrum sessions. We have a public channel where we post updates and recordings from our demos. So if you are interested in some features or experiments that we run, but also new improvements in the software, how you can adopt our software, you can also check our YouTube channel. That would probably it. So thank you for your attention, and yeah, that's it.
Fridolin, thank you so much for your talk. It was quite deep and very specific. Thank you. One virtual applause. And now we have time for the questions. Please use our Slido channel with hashtag MLMU. And we are waiting for your questions. In the meantime, the next talk, the next MLMU talk will be held on the 28th of January. Guys from Seznam.cz will have space for the thoughts. Still no questions yet. Okay, we got first question.
So there is one question: if I want to resolve dependencies, for example, for Java projects or other technologies, where would I start? I'm not big fan of Java, so I'm probably not the right person to ask. But in case of Java, there are resolvers such as Gradle, Maven, that take care of project dependencies. And I must say that Java has different aspects how to resolve dependencies. So there are also issues that can be seen just specifically for Java, like I don't know how they call it, like dependency shadowing or mediation or something like that, where one dependency from one project can shadow another dependency from another project. And that's not the case for Python, which has other issues on its own. So specifically for Java, that would be Maven and Gradle.
Thank you. Here is the last call for any question from you, and then we will move to randomized chat rooms. Okay, Fridolin, thank you once again. Next talk will be held in 2 weeks, so see you soon. Right now, you don't have to disconnect. We are randomizing small chat rooms where you can chat between each other and discuss everything you want. Thank you for your patience and for your focus. See you in 2 weeks.